So I've been getting this question a lot, how to add a full back pocket on an MDF door. Well, depending on the time of the year, the material that you get, you may run into some extra warping issues that a regular back route can't take care of. So this is your classic 60-degree route at around 330 seconds deep and roughly 2 1/4 or 2 1/2 from the perimeter edge. And you'll notice that the door I'm doing this on is a slim shaker. This will work on any door. It's a relatively easy process, it's just not very intuitive, so I thought I'd make a video for it. And with the slim shaker or any door where you're nearly doing full face machining, you're more likely to have warp going on, so the back pocket is not a bad idea. Now just watch out when you do these, you will have to shim the back side. There is an advanced way of actually adding built-in shims that we can kind of clip off with a hand router afterwards, but this is going to be the basic back route version, and I'll use formulas. This will also be a really nice intro to formulas for anyone who might be a little intimidated to do that. All right, so let's jump into it. I'm going to get out of the 3D viewer. I will go up to libraries and doors. All right, I've got a little test area in here. A couple doors. We have a shaker door, slim shaker door, and a drawer. I've also got a couple slabs in here. So what we're going to do is we're going to edit the slim shaker door, and I'll just make a copy of this. And after DR, which stands for door, obviously, I'm going to put back pocket. You could put BP. I like to put whatever deviation from the standard, I like to put it in all caps. Say back pocket. And then we're going to click on the panel and edit. Now this is going to bring us into the shape tab. We are going to bounce over to the operations tab here. And you'll see we're on the front face. We're going to click this arrow to flip around to the back face. And we're going to make our own toolpath back here. And we're going to go over here to pocket, and it will make a generic pocket. Previously I've showed you how to use anchors in other videos. That's not really the pro way to do it. So we're going to get into TOMM, right? So probably all seen this before. We're going to go 2.25 times TOMM. That will bring us 2 1/4 inch from this edge over here. This is XY00, or 2 1/4 from the X direction, right? And then down in Y, we're going to do the same, 2 1/4. You know, if you're like, well, I don't want to know this kind of thing, don't worry about it. Just type exactly what I'm typing, and then you can get the heck out of here. So the next point we're going to go over to is the bottom right. Click on the calculator for Y. I'll type in 2.25 times TOMM. And now this is about as advanced as it gets for these back pocket operations. For the X, we actually want to reference off the other side. So we're going to say part L minus, and then in parentheses, open that up. In parentheses, we're going to do 2.25 times TOMM and cap that off with another parentheses. I kind of like to just copy and then paste this to the other ones. But what that does is we have part L here. It's going to take part L, which in this case is 24, and we're saying 24 minus 2 1/4. That ends us up in the right place, and it's parametric. So now if we change the shape, everything will kind of stick with it. So let's just finish this thing off. X is going to also be part L minus 2 1/4. You'll notice I am being case sensitive about this. That doesn't really matter. This next one is part W because we're going from the other direction. I kind of just like to keep it tight and OCD with these formulas because it does help you if you're going to get a little more advanced, in my opinion. Okay, and then this last one on the Y, part W minus 2.25 times TOMM. We are done with formulas. Next, you'll notice I clicked off. I could click on one of these points down here to get back onto the pocket, because we still need to figure out the depth, fill that out, the toolpath, and the pocket. But if you just click on a point, just be careful because when you move these accidentally, if the blue goes away with these formulas, then it's no longer parametric. All right, so I've clicked on one of these points of the pocket toolpath, and I can put in, I'm going to do an 1/8 inch back pocket. You could make this parametric and put the user parameter inside of your job params, but not really necessary. So we'll just say 0.125. Then next we have to pick a toolpath. I haven't made the toolpath yet, so we're going to skip that, and then we're going to go to pocket. And as long as you're on 13.1 or later, you're going to have this use pocket tool. We're going to pick that, and then whenever you do this, you always want to pick inside out and then clockwise. That makes certain that you're not starting on the inside and then you get this little niblet in the middle that breaks off, and then you have to, bondo a little crater in there. All right, so the only thing we need to do now is do a toolpath. So if you look at this in 3D, we went 2 1/4 from the edge so that we have enough room for our hinge. And you'll notice that the 3D viewer is actually showing this as a sharp corner. But depending on our pocketing tool, we're going to have a big old radius left over in those corners. We want to do a clean out. Essentially the same as we would do on the front side on a shaker, a slim shaker, pretty much any MDF door. So I'm going to say OK. It's incomplete so far. Let's touch on this. So I did edit this door, and now it's grayed out. So I can no longer change these margins, right? I'll show you a little trick for being able to change the margin, and then we'll copy and paste that toolpath later on. But first, let's just go over to the optimizer. You can go to View and then Optimizer. Got it open down here. All right, so let's crack open Libraries, CNC Tooling, then we're going to go to the panel tool groups. So up at the top here, you'll see S004 Slim Shaker and then S004BR Slim Shaker. This is just kind of my naming system for door profiles. It allows you to very easily identify the doors and the panel tool groups, especially if you have multiple profiles going at once in your system. If you're just doing shaker, it's not that big of a deal. But so we've got the Slim Shaker. You see we got the classic 1/2 inch down shear, 1/8 inch down shear, and 30 degree. 30 degrees just to get a nice clean corner. And if we go to the BR, this is the back route. It is offset because remember this is a slim shaker. And our slim shaker is set to 1 inch. So I did a little 1 1/4 offset for this back route so it doesn't look too weird on the back side. And of course this back route we're really only using for the doors. It does give us a little anti-cupping, barely, but it does give us some. And now we're going to make our back pocket toolpath. Really, we don't need to make a specific one for Slim Shaker. We just need to make a specific back pocket tool group for back pockets in general. So for an 1/8 inch back pocket. So we will just copy this one. All right. And I'm going to do like maybe an S000. So it comes to the top of the list. Get rid of that. Could leave the Slim Shaker if you want a designated back pocket. You could do like a S004 EP and then a back pocket, but I'll make a generic one that you could apply to anything with a 1/8 inch back pocket on the back. S000 back pocket. Then we're going to do 1/8 inch. That part is important. So back pocket, very counterintuitive. You would think that you need to have it on the back side. You actually need to have it on the top for it to show up on the back side because that's where we have our pocket operation. So I will get rid of this 30 degree that is technically going to be on the back side of the door. We don't need it. It's too much machine time. It's not worth it. So on the back here, I would leave the 1/8 inch and the 1/2 inch down shear. If you're using a different tool, you can always left click twice and pull in a 3/8 down shear 7/16. I wouldn't go lower than the 3/8 unless you're using a pretty small pocketing tool. Now keep in mind our pocketing tool has already been assigned to our door, so we really only need down shear, mid-size down shear, and the 1/8 inch down shear. If we zoom in really close, This is kind of a classic basic scenario in machine doors. We have the 1/2 inch down shear. Take off the tools to see that green line. That green line represents the inside of the stile and rail or the inside of our pocket. We're actually going on the outside of that pocket a little bit to keep that 1/8 inch down shear engaged. Roughly 10% of the diameter is what you're looking to engage it with. Alright, so I'm going to quit yakking here. I think. Actually, I'm not. Okay, so this is the 1/8 inch back pocket. We need to go an 1/8 inch deep. We already are. Great. And we're done here. Gonna go into libraries, doors, going to click on our back pocket. Now click on the panel, edit, go to operations tab, flip that bad boy over, and carefully click on the point. Alright, formulas are still there, depth is still an 1/8 inch. Now we want a clean out tool. So instead of just applying a regular tool, we'll click on panel tool group and we'll pick that 000 back pocket 1/8 inch that we did. So our back pocket depth of the tool group matches the pocketing tool depth of the operation for inside out and clockwise. Now we could actually run this thing and we'd be good to go. Really all there is to it. The last tip I'll give you, that we're going to do a whole bunch of stuff if anyone's still listening, but let's go around the backside and I'll go back in operations. This is the tip for editing this door now, or you've made your first back pocket, you can pretty much copy and paste this to any door you want in a global library environment or just on a single door override. So I'm going to take my mouse, left click and highlight all 4 points. And then I'm going to go up to here and click the copy button. So I've now copied that toolpath. The only way I can copy and paste that toolpath properly is if you have formulas in the X and the Y for all 4 points. Now this is kind of cool too, because if you do want to edit this door, you'd have to click on the door, reset. Oh, maybe I want this to actually be 1.25 inches. Whatever reason, it's a little wide for a Slim Shaker, but we'll take it. Okay, we got 1.25 inches. Now we need to reapply that back pocket. It's already in our copy button. As long as we keep Mozaik open, it's going to remember that copy. I'm going to edit, flip it over, go to operations, and then hit that paste button. Everything is in there for us. Alright, so now we've got an 1.25 inch Slim Shaker, which I'm not too happy about, but that's okay. I'm going to go into my settings. We'll look at it on the door, and then I'll show you actually how to run the flip operation. I have it set up for a shop saver right now, kind of standard, what a lot of you are using. It can be used for pretty much every other machine. It's about the same. I guess Homag and Holzer will be a little weird because they have those mirrored origins, but generally the operation will be the same. Okay, so now that we have this door set up right here, right? I have S004 Slim Shaker and S004BR. Remember that was back route. Now I want to make this a back pocket. I'm going to click on the door, click on our S004 back pocket, and then I'll make sure that I just want this regular Slim Shaker now. I don't want anything applied to the back. We already assigned a tool group within that door. And we're saying use pocket tool. I'll do it for the wall ones as well. Do the regular Slim Shaker. Actually keep glass door off because it's okay. Awesome. And then we're going to go back into our product, and this will have changed. I didn't have these doors overridden, so I just edited that. Go to face. They're going to reset these doors here quick, just to use whatever the settings tab is using. Here, that. All right. Now both of these doors are going to be my regular back pocket. There. There. Ah, cool. I'm actually kind of glad this happened. So you'll see here, again, if you're still here, you've already got the information you need, but um, so when I reset that door, it reset it as a one piece, not a routed pocket door. So luckily we can troubleshoot this easy. Go to libraries and doors, click on the back pocket, reset this thing again, click on this middle panel, make sure you select pocket. Now we'll edit, go to operations, been here before, we'll paste, we'll save. Now we're good. We got an 1/8 inch front pocket on our slim shaker, 1/8 inch back pocket. Cool. All right, so for those of you still around, let's make sure this cuts out right for the flip operations. We could also do doors as well, but I don't have that set up in the tool group, so I don't want to mess around with that on the fly here. So before we do tool groups, right, we do want to make sure, see what we're actually using here. We got MDF white HG, that means, and we do just want to make sure that our trim amount, I would suggest setting it at 0.25 for the length and 0.25 for the width. So we'll go into optimize. Just going to do the MDF. You could mic your material if you wanted to. And 3/4 and 1 inch MDF is always pretty darn close. Doesn't usually hurt to have it entered a little thinner than it actually is, because sometimes we get a 0.75 or 0.755 or 0.76. Alright, we're back in the optimizer. Have our parts, 2 doors. Just start at the beginning. We've got 0.25 for our width and length trim. That looks beautiful. Got our parts in there. Good for us. Then we have this PAC tool set. Part spacing, give you a little pointer here. If you're having warping issues, if the doors are warping on you while they're cutting, you might have a surface tension issue. So you want to give it around 1 to 2 inches away from the edge. So you would change this width and length trim to 1 or 2 inches. And then it sounds crazy, but you do 2 to 3 inches between each of the doors. Now the cost of recutting one of those doors kind of pales in comparison to losing a few sheets on your yield, or even just one sheet. So we're going to optimize. Here this all looks good. Batch optimize. We are going to automatically flip parts. All right. So let's see what we got here. I do like to, since I guess we're just doing a flip-op tutorial, I'm going to keep going. So if we do the generate G-code, make sure you don't do your flip-op G-code from generate G-code. You want to be in view all patterns. That's where we're going to do it at the end. So we'll just take it to the finish line here. Generate G-code. We're going to say all sheets, create flip, and create primary. We'll say OK, and then we're going to add a squaring cut. I don't even know if I have the right tool set in here. See. Placeholder, placeholder. Alright, that's fine. Always good to see some troubleshooting. So we'll go to the panel tool group because it told us what was wrong. So all these placeholders, they're probably not in our tool set. This will be good because this will happen to you plenty. If you're a veteran, rolling your eyes right. If you are a veteran, you might probably not even. Okay. Go up and grab this 30°. That is most definitely our tool set. Back pocket's looking good. Check our tool set. Got the Frosty 40 mil in there, of course. Okay, so primary and flip sheet. We're going to add a squaring cut for your shop saver. Your origin point is up here in the top left in most CNCs. Top left, your pins are on the short side and this long side. This red line is just showing you the squaring cut. Mozaik requires a known dimension for that flip operation, so it's effectively just sizing up that sheet so that it knows where to put the front side operations. So you'll take this edge after the squaring cut, flip it over into your pins. And I'll say OK. We've got some successful G-code. Next, when you go to G-code, you will always run the flip side first. Flip it over, like I mentioned before, and then run the primary. Now, those are ready to go. The only thing that you might run into with your flip-flops, I did do an 1/8 inch squaring cut with a 1/4 inch width trim. That's just a little Mozaik voodoo, honestly. I don't think anyone really knows the right answer, but you could either do an 1/8 inch. If that doesn't work, there's 2 reasons why your flip-flops are not working. One, your XY0 origin is not set up properly. On a shop saver, extremely easy. I think they even machine 0, 0 marks into the phenolic now, so you can bring a 30-degree bit over, or any pointed bit. Line it right up, line it up on both sides, and then hit your XY0 button. You don't have to be touching the phenolic. Or, if you just have a spoil board with no dot on your phenolic, square off a sheet of material and set it onto your spoil board. I realize I don't have any graphics here, but I think you can bear with me. So you're squaring off a sheet that's nestled into at least 3 of the pins. Bring that 60 or 30-degree bit over to the corner of that sheet. Line it up on both sides, hit the XY0 button. Now usually they're not off by very much, but it's enough to throw off the edge boring distance on your hinges. It's extremely annoying. And your glass doors, they have a profile on the front, might come out a little weird. All right, so while we're in here, I am going to click on the single sheet. We'll just walk through that flip operation in case you still haven't figured it out. So I'm going to calculate on the front side just to show you what's going on here. Always looking at these toolpaths to familiarize ourselves with the process. And we'll say flip sheet. It'll ask us this question again. Then we have the back pocket happening right here. Beautiful. Then we have the squaring cut. So remember, don't G-code from here, please. Confusing. Let's go to view all patterns. Right, G-code. Primary and flip sheet. You're good to go. That's going to be it for back pocket. I might split this up into 2 videos. We have back pocket and we have a little flip-op action. So, can't get it? Email me. Get on the Facebook forum. Get on the Mozaik forum. Plenty of guys out there willing to help out. And see you later.